We have built some of the most sophisticated language models in human history, but they share a basic limitation. They are entirely reactive. Think of your standard chatbot as a brilliant sleeping machine. It sits dormant until you manually type in a prompt, pull the lever, and wake it up for a single response. This constant need for human intervention creates a serious bottleneck. When a business attempts to execute a multi-step workflow, like building an application or running market research, the process frequently fails because the human is forced to micromanage and spoon-feed every single step. Overcoming this requires a shift in how the software actually functions. This diagram compares a linear input-to-output flow on the left against an agentic loop on the right. Notice how the agent doesn't just generate text. It proactively creates a plan, selects external tools, and executes actions. The cycle doesn't stop when a task finishes. Facing an unpredictable scenario, it analyzes the results of its action and feeds that context back into the planning phase to try a different approach. It solves problems without waiting for prompts. This operational shift integrates AI directly into the workforce as a self-directed digital coworker. For a machine to work independently, it first needs to know how to think critically. If we want an agent to do market research, it cannot simply rely on the static data it was trained on. It needs the ability to verify information independently, moving beyond standard data fetching. This flowchart shows Agentic RAG. A standard system blindly pulls data, but an agentic loop actively evaluates it. It rejects flawed packets, looping back. Zooming into these verify gates, the agent cross-examines its research. Passing these checks flashes green, allowing verified information through. Once the agent has a verified plan, it needs hands to execute it. This is where systems use external APIs and software tools to alter the real world, a process we see most clearly in autonomous coding. Instead of writing code line by line, engineers are now delegating broad goals to terminal-based agents like Claude Code or Cursor. The developer provides the objective, and the agent takes over the execution. Look at this directory tree. The agent plans the architecture and modifies dozens of files simultaneously across the project. Notice there is no mouse cursor. The agent runs its own tests, spots bugs, and opens pull requests entirely on its own. By combining self-directed research with API tool execution, these systems remove the human from the micro-execution loop entirely. But the smartest individual agent has a ceiling. Every AI model has a context window, a limit on the information held in short-term memory. If you ask a single agent to build an entire software platform, the sheer volume of code and dependencies eventually overwhelms its memory, causing it to lose track of the goal. The solution is a multi-agent architecture. A central orchestrator agent manages the objective, delegating subtasks to specialized worker agents. One handles the database, another the interface, and a third writes documentation. Working in parallel, they handle massive projects without overloading individual context windows. We can see the ROI in real time. Hierarchical orchestration helped the company Fountain increase their recruitment screening speed by 50%, cutting workflows that used to take weeks down to less than 72 hours. These coordinated digital societies execute massive, multi-threaded projects at speeds humans cannot match. Transformative AI systems are now operating across servers and enterprise networks for weeks at a time without human intervention. But autonomous operation escalates the impact of an error. If a standard chatbot hallucinates, it generates a bad paragraph of text. If an autonomous agent hallucinates, the consequences are immediate and real. It can execute broken code, make unauthorized financial purchases, or violate critical compliance regulations in seconds. This level of risk changes the requirements for deployment. Without a rigorous oversight framework, a single autonomous error can become a systemic failure. This diagram shows how governance is changing. We are shifting away from a single audit at the very end of a task toward a continuous monitoring track that runs parallel to the workflow, checking the agent's logic and actions in real time. These safety tracks use rigid decision boundaries and unalterable audit trails. For high-stakes decisions, the system uses a human-in-the-loop gate. The agent completely stops its work at this point. and nothing moves forward until the action is manually verified by a supervisor. The professional role is changing. We are becoming strategic supervisors, directing the goals of an autonomous workforce and ensuring their actions align with our safety protocols. In the era of the digital coworker, the ultimate professional skill isn't learning how to write better prompts. It is learning how to safely govern, monitor, and delegate to an autonomous machine.